Hey everyone, welcome to nuk218 class 7. We're going to launch right in. So if you can go ahead and open KK with UV 0001, we're going to kick off. So we got a lot to get through. So this week we're actually going to perform the cloth sim to cause Michaela to collapse into cloth. The first thing we need to do is set up the UV textures. Last week, I'm in the animate tab, by the way, over in the shader section. I'll open up the render and the KK material. Last week we set up a front projection map so that camera 1 was being used to project the image of KK onto the mesh, and you'll see we set up some morphs to continue to align that across the different frames. What we haven't done is assign any UV maps. So right now, if she collapses into cloth, it would be like cloth collapsing in front of a projector. The image would stay where it is, but the cloth would ripple as it passes through the light of the projector. Instead, what we want is to glue the image to the mesh, so as the mesh collapses, so does the image. Hopefully that makes sense. So the way you do that in Modo is we add an additional layer. So here I am in the shader tab. I'll choose add layer, image map, and I'll say new image. And actually this is just a dummy because we're not going to use that for this particular exercise. So you can save this dummy image anywhere. Click OK and just say OK to all the options that go there. The new image will appear. Make sure in the texture locator section that the UV map is set to KK UV map, because that's the UV we'll be using. It'll look very odd here, but that's okay. And deselect it in the shader tree just by clicking its I column icon. There's a little refresh bug. If you move off the current frame, I'm at 150 and back again, the refresh will correct itself. So we have that deselected. The other thing we need to do is the render section is going to determine how the UV texture renders out. So in there, change the frame width to 2048 by a height of 2048. And we also, just to be safe, we're going to set up a duplicate camera. So this was a bug. I don't know if it's been fixed in Modo, but I'm going to select the camera, right click and duplicate. And I'll rename this new camera to camera 1 projector. Whoops. And now I'll go back to the projection texture that we had and change the projection camera to camera 1 projector. So we're using a different camera to project than we are the one to render the scene. A couple of other things. We want it, while we're in here, we're going to go to the material tab, set the diffuse amount to 100%, specularity to 0. So everything's 100% diffuse. I'm going to turn off any environmental material because I don't want that. In fact, you can switch over to the render tab to actually see what's happening over here. So we now have no environmental material. I've turned that off. I'm going to go to the render section, and in the global illumination, I'm going to set the ambient intensity to 1. And now we actually get our projected texture back the way it should look, like so. Alright, so I think we've got everything set up. We've got the render camera, frame width, frame height. We've got our UV set up but turned off. I just select the UV, right click and choose baked texture, and with any luck, there it goes, rendering out a UV map. Now remember, it's going to project on the front and the back. That's why you're seeing a doubling up of a face here. But actually the main texture should be where we want it. And now what we have to do here is actually save this image out. So I'll save image, and we will go to our images tab, and I'm at frame 150, I believe. I'll take a stab in the dark here. I'll save this as an OpenEXR half, and I'll say UV bakeout frame 150. Save. And now with any luck, if I turn the texture off here, turn this back on, and in the texture locator section, well, texture layers, image. I'll load an image, and I will load my baked out texture, and you'll see it correctly applies. So it's correctly baked the image data out to a final image. So now we're no longer using the front projection, we're actually using the UV rendered output wrapped back onto our mesh. And the only catch with this technique is, unfortunately, you have to do it for every single frame. So we're at frame 150, we'd now have to go to frame 151, right click, and choose Bake to Texture. It would then bake out frame 151, then we do 152, 153, etc., etc. Fortunately, I have already done that for you, so you don't have to worry, and those are included in the downloaded files this week. I actually created a batch script to run that. There's no automatic way in Modo that I'm aware of right now to batch through a moving UV texture bake. So that's kind of one of the downsides. This doesn't happen very often. It's a specific technique we're looking for that causes that. So I just wanted to show you the process, and I'm not going to spend any more time here. You're welcome to try it if you want, but we're going to go onto the simulation, and then we'll come back and I'll show you actually how to work with these UV textures to get just the right texture with the light compensation set up later on. Okay, you can go ahead and load up the KK with UV 0001 again, and what we're going to do is actually work separately on the simulation of the cloth, and then we'll move on from there to actually wrapping this all together with the texture map. So first thing we're going to do is in the shader tab, I'm in the animate section, shader tab, open render, and let's just turn off the texture for now, so we're just working with a mesh. It's easier to see. Hit the O key, make sure you have topology mode turned off so that everything looks good, and here's our moving texture, like so. First thing we're going to do is add a ground plane, so I'm going to go to the model quad, and I'm just going to add from the basic model section, model quad, basic model section, a ground plane that's going to cover anywhere where the cloth is likely to fall. That should be enough, and we'll lower it so it's just underneath her feet, like so. Spacebar to drop the tool, and I'll actually go to polygon mode here, and I did do one huge mistake, so I'll select the ground plane here, Command X to copy, because I need to actually have it on its own mesh layer. So I'll create a new mesh, rename it to ground, and paste Command V. There it is. Still in polygon mode, I'm going to select it and hit Shift D with the subdivision method set to faceted, and do that a couple of times just to give me a few more polys for the solve. Superstitious more than anything else. Alright, so we have KK, we have a ground plane, and it's time to do a simulation. So let's go to the Animate tab, and we'll do this at frame 1 for now. I'm going to change just to looking at the perspective view, so it's easier to see what's going on. And we are now going to go back to the Items tab, make sure KK is selected, go to the Recoil section, and because KK is selected, we can just click Make Soft Body, and choose now a soft body, select the ground, and choose Make Passive Rigid Body. So it's going to stay where it is. And if we just run the simulation now, we're going to get kind of this bouncy balloon effect, which isn't really what we're looking for. Alright, hit the escape key. Instead, what we want to do is we want to open up KK, select the soft body influence, and make some changes here. First up, I need to make some room first up. There we go. Set the structure stiffness, and the shear stiffness, and the bend stiffness all to 3%, so it's all fairly modest. The margin of collision will set to 0, so it's going to collide right where it is. And let's just see how that looks. Marginally different. Now, because this is a very new feature in Modo, I found that it can be a little bit buggy on the caching. It refuses to uncache even when you click clear. In fact, clear just kind of wipes the whole simulation out. So what I've been doing, which seems to work pretty well, is I'll just save Command-Shift-W to clear, and then I'll just open the most recent scene again, and you'll see now it's resolving the simulation, and I'm actually seeing a difference. So if you're experiencing problems, then that may be the issue. Now, there's two things here. What we want to do is we want her to really collapse onto her shoes. We want the shoes to stay rigid and the rest of her body to actually move. Hit the escape key, go back. Right now, the feet are just kind of popping up off the ground. So we can actually pin things to her feet, but we do that using what's called a point map. Let me bring this back down, and you'll see I've opened this up in the soft body influence section. There's a pin map. There's a pin map option, and if I go to the list, you'll see there's something called weight maps here. I'm going to create a new map just by clicking on it, and I'll call this pin map. Click OK. And now if I go to the paint section, there's actually a vertex map tool option in the list here. And this is my model. When I'm in vertex map mode and I change the texturing method, right now I'm shaded texture, I'll change this to vertex map. It actually allows me to paint weights on the points in my model, the vertices. So I'm going to choose paint, set the brush size to around about 100 or 90, and I'm just going to start brushing, and you see it turns red to indicate where my brush has gone. Now, any point that's not the neutral 0 color, which is the other color, won't be pinned, but anywhere where there's even slight amount of coloration will get some pinning. So this should allow us to pin the shoes to the ground and just have the rest of the model collapse. Let me undo that. I just want to get a little bit of heel in. There we go. That should do. Maybe that was a little too much. I should probably just shrink my brush. There we go. Alright, so now in theory the shoes should stay locked and the rest of the image will remain. So I'm going to go and be flattened. So going back to shaded texture, go to the items in soft body. I now choose that pin map, and let's take a look at the simulation now. I'm going to save file, Command-Shift-W to close all, file, open recent, bring it back in, and you'll now see actually because of what we've done, it's not really moving at all because everything's fairly stiff and it's being held up. So here's what we're going to do, and I'll version up here. In fact, I should call this recoil test _0001. And what we're going to do now is try increasing the subdivision, and we'll do that by selecting KK and going to the polygon mode. These three are the shorthand when you're in animate to vertices, edges, and polygons. Just these three guys up here. So I'll select this one, polygon, select a couple of polygons, right bracket to select them all, Shift D for subdivide, Shift D, and I'll choose an SDS subdivide, click on OK, and now we subdivide a little bit more, and I will version up to version 2, Command-Shift-W to close all, file, open recent, bring in the most recent. Now I'll hit play. It's going to take a lot longer to calculate now because we have many more polygons than we did a moment ago, but you'll see that the simulation is starting to behave a lot better. Still not quite what we want, but it's on its way. I'm going to hit the escape key. Sometimes you have to hit the left bracket and the escape key a couple of times just for the caching to recognize that you want to stop. Again, this is a fairly new feature in Modo, so it's a little bit glitchy. Open up KK, soft body influence, and let's change a couple of other things here. We'll set the drag to 0.001, give it a bit of drag. Everything else there should be fine. In the advanced section, we may want to increase the iterations so it calculates a bit more. I'll set those to 20. We can also go to the recoil section here and increase the number of steps, which should increase the accuracy of the solve. But let's see how we do for now. I'm going to save, close everything, file, open, and play. Alright, and you can definitely see that we have something coming along. Notice the feet say firmly planted. I'm going to hit the escape key. And we're going to subdivide one more time. So I'm going to select KK. And I will go ahead and select poly, right square bracket to select all. Shift D to subdivide. Click on OK. And now we have lots and lots of polys. So this is going to be really slow. Version up. Close all, file, and that's Command Shift W, which should be Control Shift W on a PC. Open recent, KK recall text, the latest, and click play. Now things are going to move very slowly, so I will pause the video. Alright, so I've calculated the first 50 or so frames, and you can already start to see a problem here in that the mesh is tearing. Let me just go ahead and play through, and you'll see things are looking nice, but we have this tearing in of the mesh. And the reason that's happening is by default, just hit escape, by default the simulation of a soft body is not set up to collide with itself. So we now have to enable self collisions, and I'll version up. And while I'm here, I actually might change a couple of other things. Let's bring the drag back down a little bit. And that all looks good. I think I'll set the position iterations back to 4. I don't think we need all those calculations going on. And in the recoil section, I set the global linear sleep threshold to 0 just to give it more juice. Everything else I'll leave as is. And I think that should do it. Margin 0. Let's give it another whirl. Command Shift W to close all, and then just go to File, Open Recent, bring it back in, and hit play. So we're back again, and here's the solve. Nice little calculation there, up to 80 frames. Play it again. Now I did cheat a little bit. I actually rendered one out and I found out we had an issue, so I went into the paint section, brought back my pin map, and actually increased the paint higher up the leg so that this whole section of foot wasn't going to move, and that way I managed to get a much more natural solve. Things were starting to explode off into different directions. So there we have it. We now have ourselves a nice little simulation. And now that we've done that, I want to address one more thing before we put all the pieces together and actually render this out. So let's take a break. All right, back in Nuke. Go ahead and go to the images folder in this week's class content and go to the HDR folder, and in there you'll find lightprobe.exr. Go ahead and read that in. We'll just talk about this for a moment. So this is an HDR image taken with a fisheye lens from my iPhone on set at the same position as Michaela and the same time of day. And the idea here is that we actually have, it was shot with two bracketed exposures. I would prefer 3 bracketed exposures. It just so happened that the software I was using on the iPhone only handles 2. If anyone knows, by the way, of any that automatically do 3 brackets, let me know. I haven't been able to find one yet. But what that means is we get a nice dynamic range where we can get quite a bit of the detail of the sun and the surrounding light, and also shadow detail and things like the trees. What this allows us to do is take this into the 3D application and let it relight the scene based on this pixel information. You'll see how this works in a moment. This is referred to as image-based lighting, sometimes improperly referred to as high dynamic range image lighting, but really it doesn't have to be an HDR image. It can be any kind of image, and basically what happens is the 3D renderer calculates the light as if it's coming off the different parts of the picture and then projects that onto your models and theoretically matches the lighting, color, and shading information of the scene. Theoretically, because it's never a perfect match, but at least it's much closer than if you were just trying to eyeball the thing. So what we're going to do is, by the way, this was just the 2 exposures were taken into Photoshop and then photo merged. And what we're going to do now is we're going to take this into Modo and use it to light our scene. So back in Modo, go ahead and load up KK Light Setup 0001. This is basically the identical scene we were working on a moment ago. I've just renamed it. But this is the one we worked on with the bullet. Recoil physics engine solve. And what we're going to do is, first of all, make a bigger ground plane. This one's fine for calculating the dynamics, but we actually want a different one to calculate the shadows. So I'll just select ground, right click, and say duplicate. We'll call this one solve ground. Whoops. And turn that off for now. And this one, the one we duplicated, first of all, I don't want this to be dynamic, so I'll make undynamic. That gets rid of its rigid body features, and we're just going to go ahead and scale this out. Actually, I should do this from the model quad view. That way I can actually position my scale parameters. Go up to Action Center, Automatic, and now I can click in here to scale center of the object. So I want to make this nice and big. It's going to receive the shadow that we want to cast. There we have it. And now we're going to add a light to the scene. So I'll add a null first. And in Modo terminology, that's called a locator. And we'll position that, just W key. We'll move it over and position it right under the mesh. And now we'll add a light. I'm going to go add, and we'll choose lights, and then choose directional light, seeing as we're trying to simulate the sun. So we're going to set light up first before we do our image-based lighting, just to get the position of the sun correct. That'll also allow us to use that to render out a shadow later. So we have our light. We're not seeing it anywhere because by default Modo doesn't show lights, so you have to hit the O key to bring up the options. Make sure you're in the visibility tab and choose show lights in any of the viewports you want to see lights as. And that's simply to keep the interface from getting cluttered, but in this case we do of course need it. So now we're going to hit the W key, we'll bring that down and out. Nice and distant like a sun. It doesn't actually matter with a directional light where you position it, but this will help us set up our shot later. And I'm going to hold down the control key to just constrain to snap to a 90-degree angle, like so. So we now have the light on the horizon lined up with our null. And so I'm just going to drag it onto the null locator, and it's now parented. So now if I select the null, you'll see, if we zoom out here, there's our light, that we can actually rotate the null, and of course the light will move with it, seeing as it's parented. Okay, so let's go ahead and set this up. We'll go to the render tab, and we're not seeing anything right now because we don't have our backdrop in the scene. Even if we turn it on, it won't be visible in our render port, which is where we want to see the shadow. So let's turn off the backdrop item, and instead we'll quickly project the image onto the ground plane. So I need to give the ground plane its material. So the ground plane selected, I press M, and I've already done this in rehearsal, but we'll call it ground plane. Click on OK, and now in the shader tree we'll open this up, find the ground plane, and we're just going to add temporarily an image map. We'll choose the use clip browser, find the image we want. You'd think you're done, but you're not, because we haven't actually front projection mapped it yet. So make sure it's selected, texture locator, change projection type to front projection, and the projection camera to our scene camera. And now if we go back over, grab our locator, and I'll change this to perspective view here, hit the O key and say I want to show lights here as well. If I rotate up, we can now see the light projecting, and in fact if I rotate around, I'll see that I was actually dead on first go around, but what I want to do is rotate this around until I'm lined up with my shadow. So I'll line up there, and then I'll adjust the height until the contour matches as well. It should be right about there. And we can turn on and off the light. And actually that's not going to help. We can turn on and off the texture and see how well we did. I think we're doing okay. You can actually compare where the skirt drops in here compared with here. In fact, maybe we should go a little lower to get that a bit further up. But now we have ourselves a light, and we can turn that texture off, and we'll be able to grab a shadow out of that later. And that tracks in nicely with the shot. Okay, version up. And now it's time to bring in our image-based light. So go to the model tab, model quad I should say, and first of all I'll create a new mesh. Where did it go? Here it is. For some reason, I'll bring it up, and I'll call this IBL for image-based light, and we'll just create a sphere. So we'll zoom in, position this sphere right where our mesh is, like so, and we want to make it reach out to where we position that light just for convenience. That's 300 and, let's just say 360 meters, 360, 360. So I'm making it 360 all the way around. Hit return, then hit the space bar to drop the tool. So I have this whopping light source here, and now I just need to kill off half of it. So I'm going to go to poly selection mode, right click and drag around the bottom half, and hit forward delete or function delete on a Mac, and then hit the W key, and I want to position that so that it's actually at ground plane, like so. So now we have a light dome, but it doesn't have anything on it. It doesn't have our image on it. So the first thing we do, we need to make a UV map for it. So we'll go to the list section here, UV maps, say new map, IBL map. Click OK. Go to the UV section, and in this case, what we can do is simply say project from view and click down. UV projection tool, I should say. Click down, and it's just going to create a map looking down, which is exactly the way our fisheye looks. Remember, we want to use the y-axis, and that'll bring it all right down. Spacebar to drop the tool, and we now have an image map. So now we need to give this a texture. So with the IBL object still selected, press M, and we'll call this IBL sphere as the texture name. And we want this to be, we'll set it to 100% diffuse, 0 specular for now. We're going to change that. Here's our IBL, like so. And now we need to add the texture. So we'll go to the shader tab. Here's our IBL sphere. We're going to add layer, and we'll choose load image. And we want to go to our images, and there's the HDR. We want to choose light probe. Click open. Now, it's a little hard to see right now, so let's go into its properties and the material section, and we'll actually go into the material transparency section and increase its luminous intensity so that we can actually see it. There you have it. And right now I don't have my lights visible here in this view, so I'm going to turn on show lights, and I can actually see where my light is, and that's where my sun should be. So now in the light probe section here, I can go to texture locator, and I can rotate about Y. Actually, sorry, I need to actually the IBL itself. Wrong thing. The items tab, rotate in Y, and I can now position the sun exactly where we figured it out to be based on that shadow. So there's no guesswork. Like that. And in fact, we might even want to bring this up a touch so it matches the position. And now we have an image-based light source. Well, how does this work? First of all, it's the wrong way around right now because all the normals are pointing outwards. We want them to actually point inwards. So just make sure we have no polygon selected. That means it'll select all of them. And with the IBL layer selected, press F for flip. And that flips the polygon so that surface normals are facing inwards like so. So now we have this thing. We're going to go ahead and go back to the shader tab, go to rendering, hang in there. I'm going to version up. I know this is a lot. You may want to go back. Okay. You may want to go back and watch this at a slower pace. But we're going back into the render tab now, and we want to go to the global illumination and turn off the ambient intensity. We don't want any ambient light. Let's make sure the environment is turned off because we don't want any environmental fakeness. There's just some default settings to create some illumination for your elements. And we'll turn on indirect illumination in here, which gives us our global illumination setting. And now we'll go to the material for the IBL sphere. We're going to turn off its diffuse amount. We don't want it generating any diffuse shading. And instead, we'll go to material transparencies and set its luminous intensity to 1. It's now one big massive light source. And we will turn off. Let's go actually have a look at how this is shaping up in the render tab. We don't currently want our directional light contributing, so we'll turn that off for now. And now, in theory, we're getting the shading of the actual 3D model being lit by our image light. There's one other thing we need to do, which is a little funky and quirky and modo specific, and that's we have to add a shader. Go to recent, then we're going to go to, add layer, special shader, and the shader we're going to set turn off visible to camera, and drop this base shader below, and now you'll see that our sphere is not going to render with the scene. So the sphere is contributing the light source, but it's not rendering out with it. And so now we have the object, in theory, now being lit by the actual lighting of the set that was shot on. We also have our we also have our where's it gone? There it is, directional light, which we will use to illuminate and create the shadow, and between them we will actually have a full solution for lighting the shot. Now how this all comes together, we're already out of time, and so I need to show you next week. But what I want you to do is see now, this is homework and we'll pick this up in the next session, but I want you to see if you can go ahead and finish this scene up. You won't have everything you need yet, because we do need to cover what to do with the UV maps, and that will be in next week's class in terms of how we take them in a nuke and massage them so that everything matches throughout the shot. But what I want you to do is, right now in our solve, if you go to recoil, the start time for the solve is at 1. Actually plan to do here is start transitioning from the live action source plate at 150 into our shot at 160, and then crumple from 160 through 240. So you want the calculation of the dynamics to start at 160. So when you set that up, start time of 160, make sure it all runs through, and see if you can get it through at least with a static UV texture just from frame 150. So go ahead and try and render out frame 150 as a UV texture and reapply it instead of the image-based projection, and then see if you can get it to crumple and have the shot set up. If you can, when we go into next week's class, you'll be all ready to do the final piece, which is to assemble this. We're going to go into Nuke, do some actual lighting division to cancel out the effects of our light, and then we're going to create the final shot and add some particles. It'll be very fun. See you next week. Feel free to bug me in the forums. I know this was a very complex week, so I'm sure there'll be questions.